how do the graphs of sine and cosine functions look. And then we will also look at transformations of those. Like we can transform any function, right? You can scale it, you can shift it, compress it, those kind of operations on these functions, and then what happens to the graph. But first we will start at how does a simple sine theta or sine x or cosine theta, how do they look? So now that we have recalled what a function is, let's go back and look at what is sine theta. So what we saw was in a right angle triangle, once you know one angle, that pretty much defines the triangle in terms of the ratios of the sides. Ratios of the sides are not going to change once you know one angle in a right angle triangle other than the 90 degrees. Because even if it is a bigger triangle, right, it has the same angle theta and 90, and this is the other angle. Then these are similar, right, by A. And if they're similar, then the ratios of the sides are the same. We defined sine theta to be opposite over hypotenuse. The opposite, that's the hypotenuse. Right? And we already know these ratios for some angles, right? These are the special angles we have studied. So over 2, over 2, over 2, and over 2. And this is 0, 1, 2, 3, 4. And then you put the root. Correct? So this is 0. This is 1/2. This is root 2 over 2 or 1 over root 2. And this is root 3 over 2. And this is 1. These are the special angles, and then the other values will also be there. So this is your input, and that is your output, right? So if theta is going in, then sine theta is coming out. Right? So this function is sine theta. But there's nothing special about theta. Theta is just the name of a variable. So if you put in x went in, then sine x would come out. Right? If w went in, then sine w would come out. So these are just, even if we use different variable names, it doesn't change the fact that an angle is going in and its sine ratio is coming out. I'm trying to reinforce the idea how sine theta is a function, right? You can give it different values of the angles and it gives you the various ratios. But for any one particular angle, there is only one ratio. For different angles, you can get the same ratio, that's okay. That is, different inputs have the same output, that is fine. But for one input, there can only be one output, which we also test by the vertical line test on the graph. So this is the unit circle, and the 3 of the special angles are marked on it. The pi over 6, pi over 4, pi over 3, or 30, 45, 60, and 0 would be here, and 90 would be here, right? Pi over 2. And then the other quadrants are symmetric, so we can mark those as well. I would like to graph it on this side. The coordinates for any point on the unit circle, like we discussed earlier, were cosine theta, comma sine theta, right? So this is 1. And the height is the sine theta, right? This is theta. And that is sine theta. As the dot goes around the circle, this is 0, pi over 6, pi over 4, pi over 3, pi over 2. And then if I do 2 pi over 3, 3 pi over 4, right? Pi over 4, pi over 2, that is 2 pi over 4, 3 pi over 4. And this one, 5 pi over 6, this is pi. So if we go around the circle one time, how many radians does theta go through? Going around one time brings you here, which is 2 pi. So this will be theta here. Input is theta, right? We do input here and output here, right? This is sine theta. Y equals sine theta here. And we will go from 0, this is 0, and we'll find a 2 pi here somewhere. So let's say, so 0, and I'll put a 2 pi here. So we haven't done anything so far. We just preparing to plot the graph. Theta will go from 0 to 2 pi, will go around the circle once. And we will be able to, we'll try to plot it here. And also this is pi and this is 6 parts, right? So this is, so when theta is pi over 6, this is the height, right? So sine theta is this height, correct? Sine theta. So for when theta is pi over 6, this is sine pi over 6 is this height. So at pi over 6, this is the height. The y coordinate is sine theta. The height is the y coordinate. For pi over 6, that is sine pi over 6 is this height. Pi over 4 is actually halfway of pi over 2. This pi over 2, pi over 4 is here. Half of pi over 2. So pi over 4, this height is sine pi over 4. So if I come here, and then this height is sine pi over 3. And pi over 2 is 90 degrees. This is where pi over 2 is, right? So for pi over 2, it's here. 2 pi over 3, which will be same as pi over 3. And 3 pi over 4 will be here, and which will be same as pi over 4. And then 5 pi over 6 will be same as this one. So it is here. At pi, it will be 0. Right? Then we continue beyond pi. So then we have this value here. As you went around the circle, your height first increased, right? First your height increased. It's like the Ferris wheel, right? From here, you went up, then you came down, you came to the lowest part, and then you came back up. And we only looked at the special angles, but you're also going through the angles in between, right? So if we drew this line for every angle, this will become a continuous graph. And what will happen if the circle, if you keep going around the circle? So after 2 pi, if you keep rotating, then the angle will keep growing, right? After 2 pi, it will 2 pi plus pi over 6, then you're again here, right? Then this pattern will repeat. Right? And on this side also. If you rotated the Ferris wheel in the other direction, then it will be negative, right? So if you went clockwise, then the theta will now be negative. So if you keep going in that direction, this will keep repeating in both directions. This is called one period of the sine wave or the sine function. And it's called a period because it repeats. Anything that repeats is called periodic. Periodic means repeating. And one period is what repeats. Okay, so this is a part of the sine function, right? It keeps going in both directions forever. And as you can see, this highest point is 1 and the lowest point is -1, correct? And we can pick any portion of this. So from here to here, right? that portion is repeating, right? But I could also take from here to here, and that is also repeating. I could take from here to here, and that is also repeating. All of these have the same width. This width, they're all the same. This width is called a period. You could take any portion of the sine wave that is that wide, it will repeat. But we typically work with either this one, negative pi to pi, or work with 0 to 2 pi, because that keeps things simple. What is this point? 2 pi. If it is labeled 1, 2, 3, then 2 pi you have to recognize as a little bit over 6, right? And this will be pi. Is 3.14 here. This line, the line that goes right through the middle, is called the midline. The maximum distance of the highest point from the midline, which is same as this one, this is called the amplitude. And a simple way to find that is if you take the difference from here to here, and it is half of that, because one amplitude is here, one amplitude is here. This is the max, this is the min. So here it is very obvious because this is just sine theta, right? But we will work with the transformations of that, and then it will be easier to use this way to find out the amplitude. What is midline? Midline is just the average of those two. So midline will be this equation of this line, right? So this will be y equals max plus min over 2. Right? Average gives you the midpoint. So this is the midpoint of max and min. And the amplitude will be half the distance between those. So the distance between max and min is max minus min, and half of that will give you the amplitude, right? And period, we already saw for sine, this is the period, 2 pi. Frequency is how many times the period repeats in 1 unit. This is a transformed sine function. We will look at these in a moment. But now you see the 3.14 is here, right? That's not the period, right? Not even 6.28, right? Because normally it is 2 pi, which would be 6.28. But let's see what the period is here. So this is pi, right? And you go around this and you come back here. What is the period here? If you look at it, there are two periods fitting in one. In one, there's one period and then two periods. So this one period is half, right? 0.5. So one period is half. This is the period. And how many periods fit in 1 unit? 2 periods and 1 unit, whatever that unit is. Okay. This is called the frequency. So frequency is 1 over period. Period will be 1 over frequency, right? They're reciprocals. What if period is 2? Then what is the frequency? Frequency can also be a fraction. It can be less than 1. That just means you only got half the period in one. For sine, right, just for sine theta, we know that period is 2 pi. What is the frequency? 1 over 2 pi. Don't be worried or confused. What does 1 over 2 pi mean? It just means 1 over 2 pi. Pi is about 3.14. But 1 over 2 pi is the exact value. It is less than 1, right? 1 divided by 6 point something. These are the important concepts. Other than that, there are these intercepts, right? It crosses the x-axis at 0, pi, 2 pi, right? Then 3 pi, then 4 pi. This was 0, pi, 2 pi, 3 pi, 4 pi. And if you go the other way, this is negative pi, negative 2 pi, negative 3 pi. At every pi, it becomes 0. 0, pi, 2 pi, 3 pi, 4 pi, and on the other side, negative. Those are the intercepts. And y-intercept is 0 because it's crossing there.